Hi there, this is Crisanto. I did my project on a species of parasite called Schistosoma hematobium. They're also known as blood flukes or schistosomes, and they're a parasitic flatworm, and they come from the Schistosoma uh, genus. And blood flukes are important because they're the cause of one of the most largely unaddressed diseases of poverty in the entire world, um, called schistosomiasis, also known as bilharzia in some places, and some people refer to it as snail fever. And this waterborne parasitic disease is one of the most rampant, right behind malaria, affecting over 200 million people across 76 countries. This particular species is prevalent in parts of the Middle East and sub-Saharan Africa. And I will share with you my graphic novel. The target audience is student professionals, particularly in the science and health field. And just, I've been thinking about how science, and particularly microbiology, has been applicable in my life. There's a lot of value in understanding how microbes function, how we live alongside them, especially in the pathogenic sense, because those of us that can't even get like the most basic education, um, can link with the most marginalized people, with the poorest people in the world. There's over 200 million people that this is affecting. There's a lot of opportunities to share this knowledge, and help people solve their own problems in their own communities. And you don't have to be an expert to do stuff like that. You just have to go, link with them, share. Easier said than done, but it's so needed, to be spreading our expertise in this way. So, graphic novel. When I was your age, I was sitting right here on the riverbank the day my sister came home with 2 university students. She called the whole village together, and alongside the students taught us why the river has made us sick. What made us sick was not bad deeds or the ghosts that curse water. They taught us about the parasite that burrowed through our skin, a flatworm called Schistosoma. Since they rove through our blood vessels, they're also known as blood flukes. This one is Schistosoma hematobium. They taught us about how the flatworm looks for us in the river. The hematobium reproduces inside the human host, and fertilized eggs exit the host through the urine. And once they're in the water, they swim, and develop into ciliated larvae called miracidia. The miracidia finds an intermediate host, the Belianus snail, and inside of that snail, they go through asexual reproduction that results in a motile or a mobile larva called Cercardia. And the Cercaria respond to changes in light and temperature, and they're also attracted to fatty acids on human skin. And once they find its human host, it attaches to the skin and then penetrates. And in humans, they cause schistosomiasis, also called bisharia, and we call it snail fever. Once the Cercaria find its primary host, us, they attach to the skin with its suckers. And to pierce the skin, they secrete an enzyme that widens the hair follicle large enough for the larva's body to enter into the bloodstream. It makes its way through the circulatory system, heading for the veins surrounding the bladder, where it will ultimately grow into adulthood. On its way to the bladder, many of these larvae are killed by our own immune cells, even though S. hematobium has the ability to coat itself in molecules that keep the immune system from suspecting it as an invader. S. hematobium blood flukes get nutrients from human blood, specifically the red blood cells that carry oxygen from our lungs to the rest of the body. It metabolizes the blood through its gut and can absorb the nutrients directly through the surface of its body. And since the flatworm makes its home in the blood vessels surrounding the bladder, it's constantly bathed in the nutrients it needs for growth. To reproduce, the male blood fluke envelops the female in a cleft that runs along the length of its body called a gynocophoric canal, and they stay coupled for their entire 3 to 4 year adult lifespan like this, and laying 500 to 1,000 eggs a day. The eggs that don't penetrate the walls of the host bladder get stuck and aren't able to exit the body through urine. The infection brought on by these stuck eggs are the main cause of bilharzia, rather than the flatworm itself. The human body's immune cells try to fight the blood fluke's eggs as an infection and create an immune response where the cells surrounding the eggs clump together, eventually building up so much that lesions are created and the cascade of symptoms of schistosomiasis onsets. And my sister brought us to the dam. The mining company built 10 years before. When the dam came, the prawn disappeared. There was nothing to eat the snails that parasites need to grow. This is when the snail fever started. But we fought hard against the dam and the mining companies to get the river back. When the dam was released, we started to see the prawn again. You can still find a few snails the parasite used to use here, but the fever has gone from us for good. Thank you.